All right, well, welcome. Good afternoon, everyone. Today we're starting our Math 120 class, and the first chapter is real number system. In the real number system, our aim and objective for this topic is to help you understand numbers and how numbers operate, and how we can use numbers to solve our mathematical problems. So in this class, in the real number system, we're introducing you to all types of numbers, which was the first thing your lecturer did. So with me here, I was able to outline everything that the lecturer taught in the last week's Math 120 class. I was able to bring them out so that I can make you understand better. And the first thing the lecturer mentioned, he said real number system. He talked about sets. He talked about integers. He talked about rational numbers, irrational numbers, prime numbers, before he now went to intervals, right? If you have your last week's note at FOS, I'm following your lecture, as I told you, as I promised you. We are following your lecture back to back. So many students were confused about that last week's class. So by the end of this class, it's my hope that you'll be able to understand everything the lecturer taught last week. You should have gotten it this week. Everything the lecturer taught this week, you should get it next week, because I've gotten a note of what they taught today. Are we together? So the lecturer started by introducing to types of numbers, which is normal. When you understand mathematics, the students should understand what are numbers first before you even start going to the tougher topics. So without wasting much time, we have different types of numbers. And that's why all types of numbers fall under the real number system. All possible numbers in mathematics, they fall under the what? Real number. Because class, real number is the superset of all other numbers we have in mathematics. Real number is the superset of all other numbers we have in what? Mathematics. Class, any possible number you can think of is a real number. Is a what? Every possible number you can think of in mathematics is a real number. So real number is like the air. That's what the subheading is real. That's what the lecture says, real number system. Now, coming from real number system, we're going to be looking at other types of numbers under the real number system. We have what we call the integers. We're looking at the integers, which your lecturer mentioned. We're looking at the rational numbers, which your lecturer also mentioned. We'll be looking at the irrational numbers, also mentioned by the lecturer last week. This is last week class. Remember, these are our first Math 120 tutorials. These are our first Math 120 tutorials. So starting with what lecturer started from chapter 1 last week. That will cover this week's own too. So integers, rational numbers, irrational numbers, mention irrational numbers. That's what we call natural numbers. Natural. That's what we call prime numbers. Prime numbers. So let us start with integers. Please write down integers. 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 Integers are a set of all positive and negative whole numbers. Integers are a set of all positive and negative whole numbers. Set of all what? Positive and what? Negative whole numbers. All positive and negative whole numbers are integers. So for you to be an integer, you must be a whole number. If you're a decimal, you cannot be an integer. You must be a whole. So keyword there is whole number. You must be whole. You cannot be in parts. You cannot be in fractions. You cannot be in decimal. You must be whole. It's a set of all positive and negative whole. So you could be positive, you could be negative, but you must be a whole number for it to be an integer. So you can be minus 5 is an integer. 5 on its own is also an integer. 10 is an integer. 100 is an integer. Minus 200 is an integer. As long as it's a whole number, either positive or you're an integer. Now, let's go to rational numbers quickly. Rational what? Numbers. Rational numbers are numbers that can be expressed in the form P all over Q. Rational numbers are numbers that can be expressed in the form P all over what? Q, and where Q is not equal to 0. Rational numbers are numbers that can be expressed in the form P all over Q, and where Q is not equal to 0. Rational numbers are numbers that can be expressed in the form P all over Q, where Q is not equal to what? 0. Q must not be equal to 0. Where Q is not equal to what? 0. Rational numbers are numbers that can be expressed in the form P all over Q, where Q. So class, rational numbers are your common fractions. 2 over 5, 3 over 5, Rational numbers that can be decimal or fraction. They could be decimal or what? But the key word there is that they are resolvable fractions. They are resolvable decimals. They are rational numbers. That means when you press 2 over 5 in your calculator, you're going to have a reasonable decimal that will stop somewhere. If you say 2 all over 5, you know there's decimals 2 all over 5. You say 0.4 and it ends there, right? And there's some decimals, the same 2 all over this. You say 0.567556. It keeps going to calculator. Those are irrational. They are what? They are all resolvable decimals. For example, if you press root 2 in your calculator, you keep saying 1.414. You understand? So they are what they are not. They are not. They are non-terminating. There's what we call non-terminating decimal. So we have what we call terminating decimals and non-terminating. So rational numbers have a terminating end. 2 over 5, 0.4. There's no other number. But there are some numbers that keep going on and on and on and on. Those ones are irrational. So it's safe to say that irrational numbers are direct opposite of rational. Irrational numbers are what? The direct opposite of what? Rational numbers. So we can say irrational numbers are square roots of prime numbers. You can write irrational numbers can be square roots of what? Prime numbers. All square roots of prime numbers are irrational. All square root of what? Prime numbers are what? Irrational. Numbers that are not easily resolvable. So we can say irrational numbers are what? Square root of what? Of prime numbers. So they are numbers that cannot be expressed in the form P over Q. Class, hello. Rational numbers can easily be expressed in the form P over Q. Any decimal that you can change to a fraction easily, they are a rational number. They are what? But class, there are some decimals, they say change it to a fraction. You would have to approximate first or do one adjustment for you. You cannot just change them directly to a decimal. Those numbers are said to be irrational. Are we together? So square, they have a popular example of irrational number is square root of all prime numbers. They are what? Irrational number. We are coming to prime number. In case you are lost, we are coming to prime number. Let's go to natural numbers. Natural numbers. Quickly, natural numbers. I think I've mentioned this somehow in one of our tutorials. Natural numbers are also called counting numbers. They're called what? Counting numbers. The numbers you used to count every day. I give an example. I said if you are given some money to count, what number will you naturally start with to start counting? 1, right? 1, 2, 3, right? That's how you count. So they are counting number. Nobody starts counting from -1 or -2 or 0, right? We start counting from 1, 2, 3. They give you a cash to count now. 1, 2, 3, right? So it means the natural numbers cannot be negative because you don't start counting from negative, right? So natural numbers are a set of positive whole numbers. They're a set of what? All positive whole. Natural numbers are a set of positive whole numbers. Natural numbers are a set of positive what? So it means that we can also call natural numbers positive integers. Positive what? Because integers are a set of positive and negative whole numbers. But natural numbers are only a set of positive whole. So the positive part of the integers is a natural. So natural numbers can also be called positive. Do you agree? Positive integers, because a set of positive whole numbers. Natural numbers. Natural what? Numbers. So of course you don't need an example for that one. Now, 1, 2, 3, 4, 5, 6, 7, 8. Now let's go to prime numbers. Let's go to prime. What are prime numbers? What are prime? Prime numbers are numbers. Prime numbers are numbers that are divisible by themselves and 1. So prime numbers are numbers that are divisible by themselves and 1. Prime numbers are numbers that are divisible. They are what? Divisible by themselves and what? 1. It means that for you to be a prime number, you have only 2 factors. Prime numbers have only 2, itself and 1. Prime numbers have only 2 factors. Itself and prime numbers have only 2 factors. Itself and 1. So what are examples of prime numbers? We'll start with 2. Please note that 1 is not a prime number. 1 is not a prime. Most students usually think that 1 is a prime number. 1 is not a prime number because 1 is itself already. For you to be a prime number, you must have 2 factors. You must be able to produce 2 factors, yourself and 1. But 1, unfortunately, 1 is already 1, so you cannot produce another factor again. Are we together? So prime numbers must have 2 factors, itself and 1. For example, 2. 2 is a prime number because it has 2 factors. 2 itself, and when we say 2 factors, that means 2 numbers that can go in that number without any remainder, without any 3 is also a prime number. 3 has just two factors, 1 and itself. 7 is a prime. 5 is a prime number. I was not actually going sequentially, but correct, 5. Can keep going on and on and on. Is 10? Did someone say 10? 11. 11, correct. After 11, what's the next one? Can say 13. Good. So you can now see why. You can now see why irrational numbers are square root of prime. So imagine finding the square root of 7. Do you understand? Now, other types of numbers that are worthy of notes. One of them, I'll call it, because it's in your exam, it came out last 2 sets, perfect number. They asked the students to determine which of the following numbers are perfect numbers. I've also mentioned it in class somehow, right? In 1 or 2 of our classes, but since this is on record, let me say it again. Some people might not have been there. Perfect numbers, write down perfect. The lecturer didn't mention it in class, but just go to your past question class and see some questions that the lecturer has taught that topic and you don't mention anything in that topic, but it's in the exam. It's in the what? Maybe it's possible now. This FOS lecture I don't mention it. Then those one learning MBA1, he might mention it, but MBA1 has not started learning yet. So for 2 weeks consistently, now MBA1 has not had Math 120 lectures. The college will have lecture. So college and MBA1 has not had any Math 120 lecture. Are we together? So what that means now is that when the lecturer comes in, please someone come and carry this boy. Let me feature you. Come and carry him, please. Unless we'll be showing the video. Let me just move him. Nobody likes baby here. Yeah. No, not tell him outside though. Let him be watching. You can start falling in love with mathematics now. Drop him there, drop him there. Or the other feeling will climb again. Now, perfect numbers are numbers whose, write down perfect numbers, they are numbers whose factors can be summed up to give the number. They are numbers whose factors can be summed up to give that number. They are perfect numbers. Perfect numbers are numbers whose factors can be summed up to give the number. Class. If we are to mention the factors of 6, 1, 2, 3, and 6. Let us take out 6 from the equation and add the remaining 3 factors of 6. If we add these numbers up together, it will end up giving us 6. This reason alone makes 6 a perfect number. Perfect numbers are numbers whose factors can be summed up to give the number. Class, there are not that many perfect numbers because not all numbers with their factors give, when you add them, will give the number. So another perfect number we have is 28. Class, if you write down all the factors of 28, 1, 2, 4, 7, 14. Of course, and 28. Every number is a factor of itself, right? But these last factors of every number being a factor, they are not improper factors. Because it's almost like partiality. You're already 28. Why are you still a factor again? But it's a factor. 28 divided by 28 will give you 1, right? It will go, yes. But all other factors of 28, except 28. If you add them up together, it will give you 28. If you say 1 plus 2, you have 3. 3 plus 4, you have 7. 7 plus 7, you have 14. 14 plus 14, you have... This makes it a perfect number. Class is a popular question. It's a popular what? Question in the exam. Which of the numbers is perfect? I want to give you an assignment, school of thought. Go and find out 2 other perfect numbers in our next math class. Tell me. Or does someone know that already? Can someone tell me any other perfect number? Let me throw it up to the class. 1, 496. Okay. 496. Let's see. You went very far. There's someone close by. There's a number close. Oh, yeah, what are the factors of 496? Oh, obviously 1, right? You went very fast. So this one is 2. 2 will clearly go. Sure. I'm not sure 3 will go in 496. I'm not sure I am. 4 will go in 496. 4 will go in 496, yes. 5 will not go, right? 6 will not go. It looks like 8 will go, or 7. The person that gave me the number should give me the factors. What are the factors of 496? For you to be sure that, sir, this is a perfect number, I know the factor. That's why I know the perfect. Yeah, tell me 8, 16, yes, 31. I'm just going based on what you're telling me now. 62. 124, yes. I think 124 times 4. Eh? 240. These are all the factors of 496. Yeah, let's add them together with calculator. Someone should do that. I know someone will show their talent. Now, yeah, let's go. 1 plus 2, 3, 3 plus 4, 7, 7 plus 8, 15, 15 plus 16, 31, 31 plus 31, 62. 62 plus 62, 124. 124, 124, 248. That's a perfect number. It's perfect. You're correct. It's a perfect. Use the calculator. I've used my head, but it's correct, yes? Hello, ma. You want to see me? I'm on record, so please. Hope I'm safe. All right, let's write down interval. Let's write down interval. Interval. Many of you, I know you wrote down the assignment I solved last week, but I'm sure you were still lost, right? You were very lost, right? Even in my YouTube video, I was saying comments, sir, thank you, you tried, but I don't understand. Sir, thank you, but I'm lost. You tried, but I'm lost. I say, no problem. I said, no. So I like your honesty and your bluntness, sir. Yeah, I don't want to be same as you tried, but I'm lost. I will not lie. I'm just copying this thing. Okay, now, so interval. I think the questions came from interval, right? Interval, inequality, right? So let us do it. Let us do that aspect. We have, now that you now know types of numbers. An interval I, write down. An interval I, interval. An interval I is a subset of R. An interval I is a subset of R. Class, when we say R, we mean real numbers. We mean what? Anytime you see capital letter R in your notes, that must have been where you started getting lost in the lecture. An interval R, an interval I, an interval what? Is a subset of R such that if an interval I is a subset of R, is a subset of R such that if X, Y, or Z is a membership of R. This symbol stands for membership. Tomorrow in our Math 110 class, I must teach you sets. I must teach you what? Tomorrow is Math 110 because you should have taught set before you learn this. That's why some of you are lost. I should come again. An interval I is a subset of R, a subset of what? Such that if X, Y, or Z is a membership of R, and Y is a membership of the interval of the real number satisfying X less than or equal to Y less than or equal to Z, then we can say that Y is a membership of the interval. Then we can say that Y is a what? Is a membership of the what? Interval. Let me come again. An interval I is a subset of R. R means real. So it means that for you to belong to the interval, you must be a real number. Who is not a real number, class? There are only two numbers that are not real in mathematics. The two numbers that are not real are minus infinity and positive infinity. Minus infinity and what? They are the two numbers that are not real. Minus infinity and what? Positive. Class, are you aware that if you ask to count all numbers from the smallest to the biggest, you're going to start from minus infinity to positive. The smallest number, class, if you're going back, that means your smallest number, minus 100, minus 1,000, minus 1 million, minus 1 billion, minus 1 trillion, minus 1 zillion, minus, till you now go back. Minus infinity. Minus what? This minus infinity means minus uncountable, minus on. So all numbers in mathematics range from minus infinity to positive infinity. All numbers in mathematics range from what? To positive. So, but minus infinity is not a real number, and positive infinity is not a real. Well, all the numbers between this minus and this positive infinity, they are real. They are what? So any number that you can lay hold on and you can count is real. Is what? Why we say these guys are not real is that we don't know who they are. We just know they don't exist because they are too far back. So they are not real to us. They are always together. So class, we say an interval I is a subset of all real. So for an interval to be legit, the content of the interval must be real numbers. Must what? Such that if X, Y, or Z is a membership of R, this X, Y, and Z are membership. When you are taught sets, there's what we call the point of a set. Normally, I should have taught Math 110 before 120. Because Math 110 will lay some foundation. Math 110 is further math. You're doing further math. This is further math. So Math 110 is sets. You should have learned all the set connotations. Everything I'm using here is a set connotation. This is a set connotation, membership. All these signs, less than, greater than. Subsets. We have subsets, we have supersets. Subset has a symbol. This is subset. This is superset. Now, sometimes a set can be subset and equal to, or superset and equal. It's also called cardinality of a set. Cardinality. Cardinality is ash. It's power of a set. Power is 2 raised to the power of the cardinality. So normally we should have done set, but tomorrow we'll do set. If you notice in your Math 110, they've taught set, right? Let's just start with set ahead. So we should have done set, but no problem. We'll do set tomorrow. In fact, that's your Math 110 workbook assignment. I'll do a video of it this night and send to the group. I will together those that I gave that workbook. I'll do a video of it this night and send on the group. The assignment, Math 110. Some people have not been given, some people have been given already. Those that have been given. Now, class, so let's explain this, right? An interval I is a subset of R, all real. Follow carefully. Such that if X, Y, or Z, who are X, Y, or Z? They are the points of the set, the members of the set, the elements of the set. The points of the set, the members of the set, the elements of the. So that if X, Y, or Z are members of this real number, and Y is also a member, is also related to the interval and the real number, satisfying this expression, class. What is this inequality expression? Follow me carefully. If you say X is less than or equal to Y, Y is less than or equal to Z, what this means? I've explained this before. That was last week, I think. This means that, class, anytime you're giving this kind of statement, this statement can be broken up into 2. It means that, first of all, X is less than or equal to Y, and it also means that Y is less than or equal to. These 2 statements in one. Class, if you notice in these 2 statements, Y occurs in the 2 of them, right? So if X is less than or equal to Y, and Y is less than or equal to Z, it therefore means that Y is a member of the interval. It therefore means that Y is a member of the what? Interval. Now, if you don't still understand, let me use a typical what interval to show you. Are we together? There's some of you here. You're not just mathematically inclined. You're not just mathematically what? But there's a good news. You're not going to do math after this first semester again. After this first semester, you're not doing math. If you're in engineering, you have no excuse not to understand though. Math and start, engineering, computer science, infotech. You are maths. In fact, math will be following you everywhere. Get ready. Now, let's look at this. Write down notation. Maybe this will make you understand. Let's learn some notations that we use in interval, in interval terminology. Notations. Notations. Write down notations. Notate on the board. Notation. Class. The lecturer gave the following notations in the class. I've also somehow mentioned this, but this is not time to explain it very well. As a good further math student, you should be able to note what each of these notations mean. Class, how do we represent intervals? We use notations to represent intervals. So if you don't understand notations, you cannot understand intervals. Class, if I tell you to mention the members of this interval I, and I say 1, 15. Class, you are seeing just 2 numbers here. But in between these 2 numbers are several numbers. So while we are learning interval helps you to shorten a particular set of numbers. You can just mention the first and the last, or the boundaries of the numbers. You can mention the boundaries of the what? But some boundaries are open and some boundaries are closed. This is what we call the open bracket and the closed bracket. Open bracket and what? Please, if someone is sleeping beside you, wake the person up. Say, guy, I cannot suffer this alone. You must join me. This March 120, I cannot. Join me in this. I know say you won't sleep. You can't escape. You must join me. Now follow me. Follow me now. In a normal layman's looking at this is just 1 and 15. Now no. But in mathematics students, class, this is not just 1 and 15. Class, this is all interval of all numbers between from 1 to 15. Including 1 but excluding 15. Class, anytime you see this bracket straight like this, any number beside it is included. Open. This is an open bracket. But this is a closed bracket. This is a what? Class, a straight bracket is called an open bracket. Also known as an inclusive bracket. Inclusivity. Why a curved bracket is called a closed or exclusive. A what? Anytime you see a number beside a closed bracket, that number is not going to be mentioned in an interval. That number does not belong to your what? Your interval. When you see this straight bracket, it means it's an open bracket. It belongs to your interval. It's open, inclusive. When you see this curved bracket, it's a closed bracket, exclusive. So class, this interval, 1 is beside the open bracket, right? And 15 is beside the closed. So this means that this interval contains numbers from 1 to 15, including 1 because 1 is beside the open bracket, and excluding 15 because 15 is beside the closed. So what are the members of this interval class? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Stops there. Just because you saw this bracket. As you stand now, you're already better than someone that is not in this class. Because you write 15. This one going to write 15. Say 15 they there now, they say, no. The more you look, the less you see. Are you following? So now, if you are in FOS, open your notes. I'm following your lecture bumper to. You see that I gave these notations. Do you remember? Check your notes. Now, A, B, just like you did not understand. So I'm teaching it again. This lecture now say A, B. What does this interval mean? A, B. It means all numbers from A to B, excluding A and. Because A and B have closed. So write down this notation. A, B means all numbers between or from A to B, between A and B, between A and what? Excluding what? A and B. All numbers between A and B, excluding A and B. So we can say that neither A or B is a set. Neither A nor B is a set of this interval. Neither A nor B. So you can say that is, continue, that is, this is the exact time your lecturer used. Check your FOS notes. So that I'm following up a lecture bumper to bumper. Check your FOS notes. He said neither A nor B is a set of this interval. Neither A nor B is a what? Set of this interval. Neither A nor B is a what? Set of this interval. Like today's lecture, I'll snap the notes now. So next week's tutorial, I'm teaching exactly what the lecture taught. So it means that you're getting exactly what you're supposed to get in the lecture, but in a softer and more explanatory manner. AB means neither A nor B is a set. That's what this means. Because they both have closed brackets. But class, since you now understand the meaning of the bracket, I want us to, everybody can we interpret this second one? What does this mean? All number between A and B, yes. Including A, excluding B. You get it now? Yeah, you're flowing small now here. So all numbers between A and B, including A, excluding B. But if I'm to write down in the term your lecturer used, the lecturer said A is a set and B is not a set. Is that correct? Is it correct? The lecturer said A is a set and B is not a. Is correct. Because A is in the open bracket, B is the closed. So all number between A and B, including A, excluding B. You are correct, class. Well done. All number between A and B, including A and excluding B. So lecturer said A is a set and B is not a member of the set. Now what of the third one, class? Let's look at the third one. What does this mean? All numbers between what? A and B, yes. Excluding A, including B. You get it? So yeah, the lecturer said A is not a member. A is not a member, but B is a. A is not a member, but B is a member. A is not because it's closed, but B is because it's open. A is not a member, but B is a member. A is not a member, but B is a member. I'm checking this mic because sometimes it used to just go off. If it goes off, anything I'm saying is not going to be heard in the video. Now, the last one, I believe we all know what this means now, right? This clearly means that both A and B are members of this interval, right? Class, that definition of interval I just gave you that you didn't understand. This is, you understand the application. And the good thing about mathematics, mathematics is the application, not the definition. Has anybody ever asked you to define in mathematics before? No. They'll give you a question to apply, right? So that's why I say, even if you don't understand the definition, these are intervals. These are all. Once you can bring two numbers together to represent a set of all numbers, imagine just these two numbers, we use them to represent 1 to 14. You have formed an interval. You have formed an. But just that the English they were using was too much, so you don't understand. But if I'm talking to a layman, what I'll tell him is this. See, forget about that big grammar the lecturer taught. What is interval? Interval is using few set of numbers to represent what? A larger amount of numbers. So imagine from 1 to 1, 2, 3, instead of going through all this stress, you just write open bracket 1, close bracket 15. I'm done. Interval. So interval is a way of shortening a wide set of numbers. It's a method of shortening a wide set of numbers. No, now. Now, let us proceed. Write down absolute value of a number x. Or just write down absolute value. Let's write down absolute value first. Absolute value. Absolute value. Absolute value. Absolute value. Absolute value. Now, under absolute value, you now write down the absolute value of a number x. The absolute value of a number x, if you watch the assignment video, you will hear me mention absolute value many times. What do I mean? We're there now. Absolute value of a number x is denoted by. Class, this is a symbol for absolute value. Another name for absolute value is modulus. Is what? Class, all these physics math, they are all linked. Who remembers when we did vectors? And we did magnitude of a vector. What's the name for magnitude? God bless you. So absolute value means modulus. Absolute value means what? And you see that this is the symbol for magnitude in physics. Also the symbol for absolute value. Also the symbol for modulus. So anything I want to write now, don't be lost. No matter how complicated it looks, don't be lost. So absolute value of a number x is given by what? X, such that if x is greater than or equal to 0, and minus x if what? X is less than 0. Well, mathematically, the absolute value of a number x are all possible what? Class, when you say find the absolute value of a number, that particular number, we have to be very careful what was inside that number. Because that number could be positive and it could be negative. That's why if you watch the assignment, we're doing case 1, when u is less than 0, when v is greater than 0. You say, why are they doing this? Case 2. You saw the video, right? Case 1, case 2, right? Because you have to account for all possible possibilities in that absolute value. Class, the absolute value of a number x is a set of x if x is greater than or equal to 0, or a set of minus x if x is less than 0. Class, let me break down. The absolute value of a number 5. Any course you don't like, pass it once and pass it what? Any course they say, what did they do that? This thing is just. Class, the absolute value of a number 5 is 5 if of course 5 is greater than or equal to 0, or minus 5 if it's what? If it's less than 0. Now 5 is not the adequate number to you, because if I'm saying 5 means I already know the number. I must use an unknown number. Now let's write down. Notes. Note, if the number is bigger than 0, then the absolute value of that number will give the number. If the number is bigger than 0, then the absolute value of that number will give the number. If the number is bigger than 0, then the absolute value of that number will give the what? Number. If the number is bigger than 0, then the absolute value of that number will give the number. Note that the absolute value of a number is never negative. The absolute value of a number is never, absolute value of a number is never negative. It's never negatives. Class, the absolute value of a number is never what? So the absolute value of 5 is 5. The absolute value of minus 5 is still 5. What I mean is that the absolute value of a positive number is the positive version of that number. And the absolute value of a negative number is the positive version of that same number. So class, let me remind you of something. Look up. In physics, if they say you find the modulus or magnitude, maybe you say square root and put that number all square, right? So if they say modulus of 5, it's actually square root of 5 or square. By the time square cancels square root, what is the meaning? Now the absolute value of minus 5 will still be square roots. Let me tell you the absolute value of any negative number will give positive because the negative will disappear. Follow me. Minus 5 or minus 5, minus times minus. Minus 5 times minus 5 is plus. Because minus 5 all square means what? Minus 5 times minus. So minus times minus. 5 times 5. And the square root of 25 is what? So the absolute value of a positive number is the number itself, positive number itself. And the absolute value of a negative number is the positive version of that number. Is the positive version of that number. I think this next subheading will help you understand better. Properties of absolute value. 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 Please, this is still the simple part of the course. So you've not done differentiation yet. You have not entered limits, integration. Those are the weaker parts of the course. Differentiation, derivatives, integration, limits, and continuity. So this is still simple. Now write down properties of absolute value. Properties of absolute value. Properties of absolute value. 1. So our subheading is properties of absolute value. One, write down. The absolute value of x is greater than or equal to 0. If the absolute value of x is greater than or equal to 0, then this implies that x is a real number. X is a what? Is a real number. If the absolute value of x is greater than or equal to 0, anytime you find the absolute value of a number and it's greater than or equal to 0, then that number is a real number. 2, another property. This was a lecture again, but probably you didn't understand, but I'm breaking it down now. If the absolute value of x is greater than or equal to 0, this implies that what? X is a real. 2, if the absolute value of the product of x and y, if there are two numbers, and the absolute value of the product, their products, is equal to the absolute value of each of them independently. If the absolute value of x and y is equal to the absolute value of x times the absolute value of y, if this exists, then you say that x is also a real number. X is also a what? Real number, and y is a real number. That means x is a real number and y is a what? Is a real number. 3. The absolute value of x all over y. That means the absolute value of a fraction. That means you have one numerator and denominator. The absolute value of x all over y is equal to the absolute value of x divided by the absolute value of y. If and only if x and y are real numbers and y is not equal to 0. The absolute value of x all over the absolute value of y is equal to the absolute value of x divided by the absolute value of what? Y. If and only if x and y are what? When I say this means are real. What is membership? That means they belong to the set of real. Their membership of this instance of membership. The membership and y is not equal to 0. And y is not equal to what? 0. 4. K for every real number. K for every real number is positive. Is what? If and only if x is a real number and k is greater than 0. K for every real number is positive if and only if x is a real number and k is greater than 0. And this implies that if the absolute value of x is less than or equal to k, if the absolute value of x is less than or equal to k, it implies that minus k is less than or equal to x and x is less than or equal to k. I've mentioned this before in the assignments. I'll give examples, don't worry. This last one, I'll give examples so you understand. There's some things you don't understand from the definition, but you understand from the application. When they apply, oh, this is what it means. Maybe just the English they're using that I don't understand. Class, if the absolute value of k is less than x, x is our unknown variable, right? K is any number. K is any number, any constant. So they say k, that means any number for every real number is positive. If and only if x, the unknown, is a membership of the real number, and k, the number, is greater than 0. Class, if the absolute value of x is less than or equal to k, if the absolute value of x is less than or equal to k, it means the minus k is less than or equal to x is less than or equal to k. Let's give an example. If the absolute value of 3, if the absolute value of x, is less than or equal to 3, if the absolute value of x is less than or equal to 3, now, k is any number, which is 3, right? Interpreting it this way, it means that minus 3 is less than or equal to x is less than or equal to 3. Follow me. Let me come again. So if the absolute value of x is less than or equal to k, if the absolute value of x is less than or equal to what? It means that this negative value of k is less than or equal to this x, and this same x is less than or equal to the positive value of k. So if the absolute value is less than or equal to 3, it means that the negative value of 3 is less than or equal to x, and x is less than or equal to 3. If the absolute value of x is less than or equal to 5, what will it be in this notation? Minus 5 is less than or equal to application. You didn't get the definition, but you go, okay, this is what it means. No worry, nobody has to define it. I never say define mathematics, number 1. Number 2, define set. Number 3, define this. You are going to apply it, yes. We are coming to that. We're coming to that. Eh? Now, write this. If y is a membership of A and B, where B is a closed bracket, what would this imply in terms of inequality signs? How to rewrite this in inequality sign? If y, if you are given y is a membership of what? A, comma B. How do you rewrite this in what? Inequality sign. Number 2, if we say x is a membership of 2 and 4, but 2 has a closed bracket and 4 has an open bracket, how do you write it in what? Inequality sign. And the last one, if A is a membership of minus 3, comma 0, how are you going to rewrite it in what? In inequality. Let's start with the first one, class. This first one means that A is less than or equal to y, but y is just less than B. Notice I don't put equal to in B because B has a closed bracket. And because B has a closed bracket, means that B is not included in the intervals. Class, Y is the key person here, is the person representing all members of this set. Y is the person, is the variable representing all members of this interval. Y is the variable representing all members of this what? Now, class, if they say Y is a member of this interval, it means that all members of Y must fall between all the numbers that are what? A must be less than or equal to Y, and Y must be less than B. We don't put equal to in B because B has a closed bracket, because B is not in the intervals. But we put equal to in A because A is part of the interval. Class, this thing you already know it, but I'm giving you in inequality terms. If I did not write this and I told you to interpret this interval, you will tell me that this is a closed bracket, right? You say all numbers from A to B, right? Including, excluding. Let's come from what you know, right? But now, if you don't want, in mathematics, we don't use English. We use mathematical connotation. Some of you, if they teach you mathematics in English, you understand. What makes math hard is when you start using all these symbols, right? Like, okay, if you clean this symbol now, and I say interpret this, you know it now, but when you put symbols, what is this? That's the problem. Interpret, you say, all numbers from what? A to B, including, excluding, you know it in English, yeah? Now, this is the mathematical, that thing you are saying, this is what it means in mathematics. What it means in mathematics is that A is less than or equal to Y, and Y is just less than B. Class, that everything you said. Mathematics people don't talk too much. Everything I say in English, you're writing one small thing, I'm done. See that thing we wrote 1 to 15, just from 1, 2, 3, 4, it's 1, open the bracket, don't waste my time. I know what, just open the 1, close the bracket, 15, I'm done. So when mathematics becomes hard is when you now transcribe it to notations, it now becomes difficult. So everything you just said now, this is what it means in mathematics. Let me now break it down. So all numbers from A to B, including A, excluding B. That's why you notice that my A side has equal to. That means including equal to means that including A, but not including B because it's not equal to sign here. Let's break it down. You see that is what we still mean. Follow me. If A is less than or equal to Y and Y is less than B, what does it mean? This means two statements. It means that A is less than or equal to Y, and it also means that Y is less than B. A is less than or equal to Y and Y is less than B. Class, if A is less than or equal to Y, if I want to start with Y, this sign will change to what? Greater than or equal to what? A. If A is less than or equal to Y, it means that Y is greater than or equal to A. Do you agree? If 2 is less than 3, does it mean 3 is greater than 2? If we say 2, follow me, is less than 3. If I want to mention 3 first, will I still use less than? I'll change it to greater than 2. So if A is less than or equal to Y, if I want to use Y first, I will not use less than again. Y will now be greater than or equal to. Do you agree? Now follow me. So the two statements that this word means that Y is greater than or equal to A and Y is less than B. Class, who is Y? Y is representing every member of this interval. Y is every member of this. This symbol stands for membership. Y is a member of this interval. All members of this interval fall between numbers that are greater than or equal to A but are less than B. Check it in what you know in English. It's not the same thing. All numbers from A to B, including, excluding. But this is not the mathematical implication. Am I making any sense now? Small. Let's go to the second one. Maybe as we do more examples, you get it. Now follow me. If X represents all members of this interval, if X represents what? Class, let's do something now. Before we do the mathematical one that confuses you. This one, what does this bracket, what does this interval mean? All numbers from 2 to, including, excluding. Can we list them? Well, this one is number now. So all numbers from 2 to 4. Who are numbers from 2 to 4? But you not mention 4, right? But 4 has a closed class. So these are the members of this interval. These are the members of this. Now, you know it, understand it. Now, let's not write the mathematical connotation. What this means is that X represents all members of this interval. So what this means is that 2 is less than or equal to X, and X is less than 4. 2 is less than or equal to, and X is less than. Let's break it down. Anytime you have an inequality or interval, it can break into 2 parts. Class, first part is 2 is less than or equal to, and second part is X is less than. Before writing this down, with our understanding, we have the members of the interval, right? Watch now. If 2 is less than or equal to x, if you want to mention x, what will happen? Greater than, right? This time we change to greater. So x is not greater than or equal to, but x is less than. So what are the numbers that are greater than or equal to 2, but they are less than 4? What are the numbers that are greater than or equal to 2? What numbers are greater than or equal to, right? So 2 is among, right? But less than 4. Is this something we got here? With our English understanding, right? But mathematics still the same. So the thing is that you know it, but you don't know that you know it yet. Because when I enter my right any symbol, it becomes how is this? But you know, I've given the explanation already. Let's go to the third one now. It's getting easier somehow, at least. Yeah, let's go to the third one. Hope I'm not too fast in cleaning. I'm too fast, right? Sorry. That's why I just told myself like I'm fast though. Let me rewrite it. So S is what? What I put to greater than or equal to 2. I'm trying to be fast for those that are staying fast so that I can close earlier. I know it's not easy. You came, some people have gone on, but you stayed back. Well done, class. Stay back 4. Well done. So I want to deal with this thing that has been confusing students so that we can now go to the other tougher parts of the course. But we still have limits and differentiation, integration. So what we'll be doing is that later teaching will be following back to back so that anything they want to set, you are covered. But don't forget, if I was too fast anyway, there's still a video for you. If you're in the register members group, you will get the video. Or this one, I might just post it for everybody. Let everybody just go and learn. Because today is afternoon class. So, are we done now? Okay. But if you understand, I can even claim because you understand, you can write it what you understand. You get? Okay, now. Oh, so this is 2 less than or equal to x less than 4. Class. This guy, I want to write it in 2 places. If A is actually E and minus 3, 0. Let's first start with this one. Since you've been following us, can you tell me what I'm supposed to write here? Minus 3, yes. Less than or equal to. So A represents every member of this interval, right? Continue, yes. A is less than. So minus 3 is less than or equal to A. A is less than. Minus 3 is less than or equal to. And A is less than. What of this one, class? When the 2 brackets are closed. Minus 3 is less than A. A is less than. None of them will have equal to. None of them will have what? Why? Because the 2 brackets are. The 2 brackets are what? What if the 2 brackets are open? A, if A, E, minus 3 and 0. The 2 brackets are open. What will it have been? Minus 3 is what? Less than or equal to what? A. A is less than or equal to. Good. Are we together, class? I haven't understood that. So don't still forget where we came from. Now, if the absolute value of x is less than or equal to k, if the absolute value of x is less than or equal to, it implies that minus k is less than or equal to x, x is less than or equal to k. If the absolute value of x is less than or equal to 3, it implies that minus 3 is less than or equal to x, x is less than or equal to 3. If the absolute value of x is less than or equal to 5, it implies that minus 5 is less than or equal to x, x is less than or equal to 5. Let's now forge ahead. I've been able to achieve something. And class, what this means in this term, class, can I now rewrite this in this format? Yes, I can. I can rewrite minus k is less than or equal to x, x is less than or equal to k in this format. What will it be? It will be x is a membership of open brackets minus k. Both of them open bracket. Both of them what? Why? Because they both have equal. So this x, the membership of this interval lies between minus k and positive k. The membership of this interval lies between minus k and, just like when we did here, the membership of this interval lies between A and B. Between 2 and 4. Between minus 3 and, the membership of the interval lies between minus 3 and 4 and 0, sorry. So the membership interval lies between minus k and k. So we can write this as x is a membership of open bracket minus k, close bracket plus k. So if you are given in this format and asked to write in this format, you know what to do. If you are given in this format and asked to bring it back to this format, you know what to do. I'll test you with one question. I'll test you with one question. If you are given something like minus 5 less than x less than or equal to 10. I want to rewrite this in this format. Minus 5 less than x less than or equal to 10. Minus 5 less than x less than or equal to. Can you represent this in a simple open and close bracket interval format? What will it be? X is a membership, right? Yes. Close bracket minus 5, 10 open. You're still understanding it. You're still understanding it. Now, good. So, I want to tell you something now. Don't forget, if the absolute value of x is less than or equal to k, what does it mean again? It means that minus k is less than or equal to x is less than or equal to k. Good. So if the absolute value of x is just less than k, but it's not equal to, when the absolute value of x is less than or equal to k, this is it, right? What if the absolute value of x is less than k? If the absolute value of x is just less than k, but it's not equal to, what will it mean? It means minus k is less than x is less than, there's no equal to, there's no what? But when there's equal to, there's equal. Now let's keep going. I haven't understood this class. If the absolute value of x is less than 1 over 2, what does it imply? If the absolute value of x is less than 1 over 2, what does it? Can you tell me? It means that minus 1 over 2 is less than x is less than 1 over. Do you agree? It means that minus 1 over 2 is less than x, and x is less than 1 over. Okay, good. Question 1, now let's go. And if you have to write this in interval term, it means what, class? Interval term, what does it mean? X is a membership, right? Of what? It is open or close bracket? Close bracket, minus 1 over. Open or close bracket? This is the interval form of what you have here, right? Interesting. Take this first question down. Find all of x in the set of real numbers. I'm using the exact example they use in lecture, so that you remember, okay, that's what I was saying that day. I remember this question, but I was lost in class that day. Find all of x in the set of real numbers. Find all of x in the set of real numbers. Find all of x in the set of real numbers. Absolute value x minus 2 equals to absolute value 2x minus 3. Find all of x in the set of what? Real numbers. Find all of x in the set of real numbers. If the absolute value of x minus 2 is equal to the absolute value of what? 2x minus 3. If the absolute value of x minus 2 is equal to the absolute value of 2x minus 3. What's time? 5:23. Let's go fast. This is actually the climax of this particular topic. This was the one that I solved that when I said, what was he doing here? Class. What we are going to say is that we're going to say, we have two functions and the absolute value, class. It is more difficult when you are given the absolute value of a function. It is more difficult when you are given the absolute value of a what? So this is not just absolute value of 2 or absolute value of 3. This is absolute value of x minus 2, class. When you are given the absolute value of a function, we don't know if that function is what we call even function or odd function. A function can be even, a function can be odd. A function can be neither even nor odd. A function can be negative, it can be positive. So this is a very dangerous question. So we are just going to be working on assumptions. We're going to say let the first function be u. So let x minus 2 be equal to what? U. So let u be equal to x minus 2. Let's give a name to this and this. And let the second function be what? V. Class, if you're watching my solution that day, that's how u and v came about. That's this one special thing. This is how u and v came. Let u be equal to x minus 2 and let v be equal to 2x minus 3. Name this function u and name this function what? V. We're not going to say case 1. For case 1, we're going to say if case 1 is when u is greater than or equal to 0 and v is also greater than or equal to. Class, what is the implication of u and v? Yes, now my friend, the question you asked, we're coming there now. We're going to come to when u is less than 0. That means when it's negative. That's when it's negative, right? Good. Class, what does it mean if we say u is greater than or equal to 0 and v is greater than or equal to 0? Remember that they did not give us u and v in our question. They gave us functions, x minus 2 and 2x minus 3. They didn't give us u and v. It's our job to say that u is x minus 2 and v is 2x minus. So when u is greater than or equal to 0 means that when x minus 2 is greater than or equal to, and when v is greater than or equal to 0 means that when 2x minus 3 is greater than or equal to, it means that they are both positive. Any number that is greater than or equal to 0 is a positive number, right? You cannot be greater than 0 and be minus. It's not possible. So it's positive number, right? It therefore means that the absolute value of x minus 2 is definitely just x minus 2. It's definitely what? Just what? And the absolute value, because u is greater than or equal to 0. So who is u? X minus 2. So we are sure that x minus 2 is a positive. And the absolute value of 2x minus 3 is just 2x minus. For case 1, when u and v are greater than or equal to 0. So what this now implies is that we can now say, therefore, we can equate x minus 2 to 2x minus 3. Because what is inside this place is still what will come out. It's still what to do what? Because they are both positive. They are both what? Don't forget to say you find all of x. What you're looking for is x. What are the possible values of x? Find all of x. Find all of. There's a reason why they use that word, all of x, in different cases. That way, you're going to have 4 cases. So now if x minus 2 is equal to 2x minus 3. Class, what? The difference between this and this is that I've now cleaned this absolute value sign, right? What gives me permission to clean the absolute value sign is that we are sure that the absolute value of x minus 2 is just x minus 2. And this is just 2x minus 3 because u is greater than or equal to 0 and v is greater than or equal to 0. So we have now cleaned this sign. I can now solve for x. So x minus 2 equals to 2x minus 3. And that will give you, making x squared to the formula, bring 2x to this side, bring minus 2 to this. So let x is already here. When 2x comes to join it, become minus 2. And minus 3 is already here. When minus 2 comes to join it, become plus. You agree, right? Signs will change, you get? Because when 2x comes to this side, the sign will change from positive 2x to negative. And when minus 2 comes here, it becomes positive 2. X minus 2x is minus x. You agree? Minus 3 plus 2. Minus 1. Minus can cancel. For case 1, x is equals to 1. If you're in the IFS note, just be checking your lecture notes. If you're in the FOS lecture last week, be checking your lecture because it will corroborate what we're doing here. And again, it will give it more credibility. Because you know, so this is what I was saying last week. I'm teaching tutorial this week. Okay, I'm in the right place. They're teaching what the lecturer taught in the lecture hall. Class, what is just case 1? The lecturer now went to go and give case 2. In case 2, we're going to say, what of if u is the only one that is greater than or equal to 0, but v is less than 0? If u is greater than or equal to 0, but v is less than, what would be the implication? Class, if u is greater than or equal to 0, means that the absolute value of v is just u. But v less than 0 means the absolute value of v might be that the number that was here was a negative number. And who is u? U is x minus 2. But v, who is v? 2x minus 3, right? But v less than 0 means that this v is carrying a negative. It means that v is carrying a what? Use this negative to open the bracket. Minus 2x. Minus times minus. Plus 3. So what we're actually going to equate now is x minus 2. We're going to equate it to minus 2x plus 3. We're going to equate x minus 2 to minus 2x plus, and find the value of x in this case. Bring minus 2x to this side, becomes plus 2. And this 3. When minus 2 comes here, plus 2. X plus 2x. 3 plus 2. Divide both sides by. So x is 5 over 3 in another case. Class. Let's say find all of x. Check the question. Find all of. In case 2, x is 5 over 3. In case 1, x is just 1. X is just what? In case 3, what is x in case 3? We have 4 cases. I can clean case 1, right? Case 1. Oh, yeah, let me be fast, please. I don't like people leaving the class when I'm teaching. So, because it's late. And so you understand. So, yes. We're going to do it too. That's what we're going to do it in case 3. Now, so as I said, when the function is less than 0, it automatically attracts a negative sign to the function. See, look at case 2. When u is greater than or equal to 0, we did not put any positive, any negative sign. U is still u, x minus. But when v is less than 0, is one that takes what? Negative. Now, for case 3 will be when u is now the one that is less than 0, but v is greater than or equal to 0. When u is less than, please, we're almost done. We're almost done, eh? Don't leave me alone here. I don't sleep here. I don't live here. We'll go together, eh? Please, quickly. Now, when case 3, when u is less than 0 and v is greater than or equal to 0, the absolute value of u, therefore, will not attract a negative version of u. But the absolute value of v is still v because v is greater than or equal to, who is u? X minus 2, right? So my x minus 2 will attract a negative sign. Protect the function with the bracket so that you use the minus to open the bracket. Now minus times x minus times minus 2 minus x plus 2. And v is just still v, right? Because it's greater than or equal to 0. What's v? 2x minus. So we're going to equate minus x plus 2 to 2x minus 3. Minus x plus 2 to what? 2x minus 3. Make x squared to the formula. 2x comes to this side. Minus x minus 2x. But when 2x moves there, it becomes minus. Do you agree? Don't just be copying. No, you already have this note from the lecture. Then you're copying again. This one you should be understanding. Try to be under. Some of you like writing a lot. This note, this is your lecture note. This is your lecture. I'm just here to make it easier and understandable. I could have come here and teach my own topic, but I'm not the one setting exam. It's good I teach what lecture is teaching you because what teaching will set. The topics you teach is one way. So it's good we follow it like that. Now, so you probably have this note already. I posted it on the group. But understanding it is what you should be looking at the board. Don't be struggling to write. Struggle to understand. This 2x comes here, become minus 2x. And there's already minus 3 here. So plus 2 comes here, become minus x minus 2x minus 3. Minus 3 minus 2. Minus 5. Can minus cancel minus? X is 5 over 3. So case 4 and we are done. Case 4 and we are x 5 over 3. I think we have gotten something like this before. For case 2. Not now. If you sleep here, just wait. After the class, you can answer you. You stay here. After the class, you can answer. Some people don't stay here. They are going home. They are going. I don't want to receiving calls. So it's, you people not done. Like that's practical days. Some parents were calling. Are you not done with their practical? Let them come home now. Where is the case 4? Case. Which one have you not done? When u is less than 0, right? And v is also less than. When two of them are less than 0, I mean, the absolute value of u will give the negative version, which is minus x minus 2, right? Which is minus x plus 2 when you open the bracket, right? We've done this before. When the absolute value of v also will give negative version, because they are both less than minus 2x minus 3. Minus 2x minus, that will give you minus 2x plus, equate this to what? Minus x plus 2 equals to minus 2x plus 3. Maybe try and understand. Don't just rush to write. Even if you don't, if I clean the board, you can watch the video and write the note again, but understand it. Minus x. When minus 2x comes here, plus equals to 3. When 2 comes here, minus x plus 2x. X is positive x, right? 3 minus 2. X is 1. We've also gotten 1 before, right? So in 2 cases, 1 was the answer. In 2 cases, 5/3 was the... How do you now represent your final answer? Find all of x. Class, this is now a full circle moment. That thing I've been teaching you is how you represent the answer of class. You must represent your answer in what's the subtopic in intervals. Remember, So x is all members of x range from what to what? Class, 1 is involved, right? So open bracket. Who is smaller between 1 and 5/3? Okay, 1 is smaller. 1, 5/... Class, this is the answer in interval form. This is what you see in option. Your exam is OBJ. Your exam is object. All the solving we have been solving, this is what you're looking for. X, all members of the interval ranges from 1 to what? Because we have x as 1 and we have x as 5/3. This is our final answer. So 1, 5/3. 1, 5/3. 1, 5/3. Or you can also say that x is a membership like this, and you open bracket 1, 5/3. You can say it this way. Are we together? Now let me just run my confusion. So please, if you've watched this video, it means you've understood the class. If you still have any questions, you can drop your questions in the comment section, or you can message me via WhatsApp. If you still have anything you don't understand, 081-824-24350. So I hope you understood this class. Thank you for watching. Yes, you can ask your question.